right, let's look at our sample quiz for 3-3 and 3-4. So to begin with, we are doing combinations of functions. So this says g divided by f. So we're going to do g of x, which was 4n plus 1, divided by f of n, which was n squared minus 5. So literally, we're just putting the g function over the n function, and that's our answer. They also asked me to give the domain. So remember, your domain is going to be all real numbers unless one of two things happens. You have a fraction or a radical. We do have a fraction, and when we have a fraction, we set our denominator not equal to 0. So I'm going to add 5 to both sides and then take the square root of both sides. Don't forget to put in your plus or minus. So that would be all real numbers except for positive and negative square root of 5. And then here is our interval notation for that. All right, then for number 2, they gave us g plus h of n. So for g plus h of n, we're just going to take g of n, x squared plus 5n right here. And then we're going to add to that h of n. So h of n is 4n plus 2. So combine any like terms you have, 5n and 4n would give us 9n. And then your domain is going to be all real numbers unless you have a fraction or a radical. I don't have a fraction or a radical, so my domain is all real numbers. All right, then look at number 3. So for number 3, we're subtracting. So I'm going to take f of n, 4n plus 5, and subtract from that g of n, so 2n squared plus 2n. So remember that negative is going to be distributed through the parentheses. It's going to change the sign of everything that came after it. So a positive 2 becomes a negative 2, and a positive 2 becomes a negative 2. And again, we'll just combine any like terms we have. So 4n minus 2n gave us 2n. And again, this was a polynomial, no fractions or radicals, so our domain was all real numbers. All right, then for number 4. For number 4, we've got g times f of x. So we're literally just going to take g of x, 4x plus 4, times f of x, x squared plus 5x. So we're going to FOIL. So 4x times x squared is 4x cubed. 4x times 5x is 20x squared. 4 times x squared is 4x squared, and 4 times 5x is 20x. And then combining like terms, we could put the 20x squared and the 4x squared together. And again, this is a polynomial, so our domain is going to be all real numbers. All right, let's look at number 5. So for number 5, we have f divided by g again like we did before, but this time we're going to plug a number in. So there are 2 different ways that we looked at to do this in the notes, and you might like one better than another. All right, the first way was if f divided by g of negative 3 just means f of negative 3 divided by g of negative 3, like you see here, then we can just go find f of negative 3. So we're going to put negative 3 in the place of t right here. So 3 times negative 3 minus 3, 3 times negative 3 minus 3 is going to give us negative 12. And then to find g of negative 3, I'm going to put negative 3 in the place of t. So that'd be negative 2 times negative 3 squared plus 3 times negative 3. So that's what we did here, and that gave us negative 27. So if f of negative 3 was negative 12 and g of negative 3 was negative 27, then that would be our answer, and we could simplify that down to 4/9. The other way that we looked at in the notes of how you could do this is if you'd rather, you can go ahead and leave the functions as they are. So again, we're going to do f divided by g, so 3t minus 3 over negative 2t squared plus 3t. So once you've got f divided by g, then you could plug your negative 3 in for x. Well, in this case for t. So I would just put negative 3 in for each of my t's and simplify. And you can see you're going to get the same answer either way. Just depends on whether you'd rather plug in the numbers first or find the equation and then plug in the numbers. All right, so for number 6, I've got g plus h of 7, which just means g of 7 plus h of 7. So again, if you'd rather create the equation first and then plug in 7, you can. But I did this by plugging the number in first. So I'm going to find g of 7. That just means put 7 in for x. So 2 times 7 minus 1 would give us 13. And then plug 7 into h. So negative 7 minus 3 would give us negative 10. So if g of 7 was 13 and h of 7 was negative 10, then I can put those together and get negative 3. All right, then for the next one, it asks us to find the function and state its domain using interval notation. And this is a composition of functions. This is totally different. Watch this carefully. So I'm going to rewrite this because I just prefer this notation. This is not f of x times g of x. All right, we did that higher up on the page. That is not what this notation means. So first off, just put your finger over this f right here, and you're left with g of n. So if you'll notice, g of n is n squared plus 2. I'm just going to replace g of n with what it's equal to, n squared plus 2. So now I have f of n squared plus 2. Okay, what does that mean? That means come up here to the f function, and we're putting n squared plus 2 in the place of n. So that's going to be 3 times n squared plus 2 minus 4. So 3 times n squared plus 2, we put that in the place of n. 3n minus 4, we put that in the place of n. So now we can simplify, so we're going to distribute that 3. So 3 times n squared and 3 times 2. And then 6 minus 4 is going to give us positive 2. And again, this is a polynomial. I do not have a fraction or a radical, so my domain is going to be all real numbers. All right, here's another one of those. So for this one, we've got g of h of t. Again, this is not g times h. Put your finger over the g right here, and you've got h of t. So if you'll notice, h of t was 2t plus 5. Let's just replace h of t with what it's equal to, 2t plus 5. So now I have g of 2t plus 5. That means put 2t plus 5 in the place of t in that equation. So like if you had g of 2, you'd put 2 in for t, right? So if you have g of 2t plus 5, you're just going to put 2t plus 5 right here for t. So we're going to have 3 times 2t plus 5 plus 5. So 3 times 2t plus 5 plus 5. So distribute your 3, and that'll give you 6t plus 15, and then combine your 5 and get 20. And again, this is a polynomial, so all polynomials are going to have a domain of all real numbers. Now, numbers 9 and 10 are just extra practice for numbers 7 and 8. If you feel like you need to do a few more of those, I did give you a couple more examples of those here, but they are just the same thing. So for this one, for g of f of t, put your finger over the g, and you're going to replace f of t with what it's equal to, negative 2t squared plus 4t. So g of this thing means put this thing in the place of t in the equation. So it's going to be 4 times that thing plus 4. So you can see it, 4 times that thing plus 4. All right, so let's distribute the 4, and that will give us 4 times negative 2t squared is negative 8t squared. 4 times 4t is 16t, and then our plus 4. No like terms to combine, and again, polynomial, so domain is all real numbers. All right, here's another one, h of g of x. Put your finger over the h, and you're just going to replace g of x with what it's equal to, which was x cubed minus 1. So replace g of x with x cubed minus 1, and now we have h of x cubed minus 1. So that means come up here and put x cubed minus 1 right here. So that'd be 3 times x cubed minus 1 minus 5. 3 times x cubed minus 1 minus 5. So we'll distribute the 3, so 3x cubed, 3 times negative 1 is negative 3, and negative 3 and negative 5 is negative 8. And again, it's a polynomial, so our domain is going to be all real numbers. All right, so these are compositions of functions just like we were doing, but now we have a number, so that makes them a little bit easier to do. So first off, I'm going to rewrite this notation, right? So I'm going to say h of g of negative 10. So put your finger over this h over here and cover it up. You're just doing g of negative 10. Okay, so g of negative 10 means put negative 10 in the place of this x right here. So negative 2 times negative 10 plus 5. Negative 2 times negative 10 plus 5 would give us 25. So if g of negative 10 equals 25, cross that off right there and just replace it with what it's equal to, 25. So now we have h of 25. So let's put 25 in the place of that h right there. So that's going to be 3 times 25 plus 2. So 3 times 25 plus 2 is going to give us 77. All right, here's another one of those. So h of g of 0. So again, I'm going to rewrite it this way. Put your finger over the h to ignore it, and we're going to start with g of 0. So that means put 0 in the place of x right here. So that'd be 2 times 0 minus 5. So 2 times 0 minus 5 is going to give me negative 5. So now that I know that g of 0 is negative 5, then I'm going to do h of negative 5. So I'm going to put negative 5 in the place of x in the h function. So that's going to be negative 2 times negative 5 squared minus 5. So negative 2 times negative 5 squared minus 5. So negative 5 squared is positive 25 times negative 2 is negative 50 minus 5 would be negative 55. Now, we did not do anything like number 13, so we said to just omit that one. Don't worry about that one. So let's look at 14. So for number 14 and 15, you're going to use this table to help you figure out these values. So again, put your finger on the F, and we're just looking at G of 1. Okay, so what that's asking you is it's saying when x is equal to 1, what's your y value? So I'm going to come over here to my table, and I'm going to say when x is equal to 1, this is going to be my g value, my y value. So this would be g of 1 is equal to 3. So if g of 1 equals 3, cross off g of 1 and replace it with 3. Now I have f of 3. Okay, so I'm going to come down here to where x is equal to 3, and I'm going to go over to the f function. So f of 3 would equal 3. So I'll replace f of 3 with 3. All right, look at another one of those. So put your finger over the g to ignore it. Let's start with f of 4. So we're going to come over here to where x is equal to 4 and go over to the f function. So f of 4 would be 1. So since f of 4 equals 1, cross that off and just replace it with 1. Now I have g of 1. So I'm going to come over here to where x is equal to 1, and I'm going to go over to g. So g of 1 is equal to 3. So g of 1 is 3. So again, remember what you were doing here was you were putting a value in for x, and you were finding y. All right, so that's the same thing that you're doing on this next problem. Now, I changed this 3 to a 2 to make this problem a little easier. It ends up, if we leave the 3 in there, we get a value of negative 1, and it's just hard to see what our graph is doing at negative 1 because that's not really clear on here. So I changed this to a 2 for that reason. All right, so again, remember we said if x is equal to 4, we're trying to find y. That's what that notation means. So same thing here. We're saying if x is equal to 2, what's y? So I can, in the g function, okay, so here's g, here's f. So in the g function, I'm looking to see when x is equal to 2, what's my y value? Well, the ordered pair at 2 is 2, 0. So when x is equal to 2, y is 0, so g of 2 equals 0. So come over here and replace g of 2 with 0. All right, now I have f of 0. So for f of 0, I'm saying when x is equal to 0, what's y? So come over here to the f function, and you can see that when x is equal to 0, that hits my graph right here at this point, 0, negative 3. So when x is 0, y is negative 3, so f of 0 is negative 3. And let's replace f of 0 with negative 3.